theorem on Pfaffian differential equation. If x bar is vector and mu is arbitrary function of x, y, z, that is scalar function actually, mu is scalar function, then prove that x bar dot curl x bar is 0 if and only if mu x bar dot curl mu x bar is 0. So proof of this theorem, uh, part 1, assume that x bar dot curl x bar is 0. Now we have to show mu x bar dot curl mu x bar is 0. So we have to prove mu x bar dot curl mu x bar is 0. Now curl mu x bar is what? Del cross. Curl means del cross mu x bar. And what is del cross? Phi into u bar. Phi is the function of x, y, z, suppose, and u bar is the vector function of x, y. Then what is the del cross phi u bar? Is del phi cross u bar, del phi cross u bar, minus phi del cross u bar. So this is the rule or theorem. Actually, it is of the type derivative. U derivative of v plus, in the place of plus there is minus. V derivative of u. That is, if there is d notation, then what is the derivative of phi into u bar? Derivative of phi into u bar and phi into derivative of u bar, like that. So it is del phi cross u bar minus phi del cross u bar. So this is the rule. Del phi means grad phi. There is no notation between del and phi. Don't write dot or cross in between this del and phi. It is del phi. Del phi means grad phi. If there is dot, then it is divergence of phi. Del dot phi is what? Divergence. Del dot means divergence. And del cross means curl. And del, just del means what? Grad phi. So by using that rule, this u is scalar function of x, y, z, and x bar is vector function. So by using this rule, we have del mu cross x bar, okay, minus, right here, minus mu, that is phi, del cross x bar. Okay, so this is by using that rule. And then mu x bar dot curl x bar is what? Take the dot product of this, that is dot product mu x bar dot this del mu cross x bar minus, here right, minus mu x bar cross this mu del cross x bar. And this mu is now, is a scalar function. So this mu, and we have this mu is a scalar function. So mu in bracket x bar dot del mu cross x bar. So this is a scalar triple product actually. X bar dot del mu cross x bar, that is a bar dot b bar cross c bar. Okay, a bar dot b bar cross c bar is the box product. It's called the box product. And this is mu, and mu is mu square x bar dot del cross x bar dot del cross x bar. So this x bar, and this is equal to 0, because in a scalar triple product or in box product, if the two vectors are same, then their scalar product is 0. So scalar product or triple product is 0 if two of them are same. So this is the concept. And so del dot so x bar dot del mu cross x bar is 0. Similarly, this is what? X bar dot del cross x bar. So x bar dot del cross x bar means x bar curl x bar is 0 by assumption. This is assumption that x bar dot curl x bar is 0. So this x bar dot curl x bar is 0 by assumption, and this is 0 by using this concept that in scalar triple product, if two vectors are same, then their scalar product is 0. So is equal to 0. And so we have the first part, that if x bar dot curl x bar is 0, then mu x bar dot curl mu x bar is 0. Then converse of this theorem. So assume that mu x bar dot, right here dot, curl mu x bar is 0. And now we have to show that x bar dot curl x bar is 0. So mu x bar dot curl mu x bar means del cross mu x bar is equal to 0. Curl means del cross. And then mu x bar dot, and they'll write the rule del cross mu x bar. Del cross mu x bar. So the rule is mu del cross mu x bar. This rule. So del mu cross x bar minus del mu cross x bar minus mu del cross x bar. So this is by using this rule del cross phi u bar. So we have this, and then this del cross mu x bar is what? Del mu cross x bar minus mu del cross x bar is equal to 0. So this is the simplification of this LHS. Then mu cross del mu x bar dot del mu cross x bar, that is distribute this dot on this subtraction, minus mu x bar dot this quantity, that mu del cross x bar, bracket complete, not bracket, is equal to 0. So after distributing, then here mu x bar, so this mu is scalar, so x bar dot del mu cross x bar is 0. This is scalar triple product of these three vectors, x bar, del mu and x bar. So this scalar triple product is 0 because x bar and x bar out of these two are same. And then this is mu, and mu is mu square x bar dot del cross x bar is equal to 0. And then this mu square is not equal to 0, so shift this mu square and negative sign. We have x bar dot del cross x bar is 0, means x bar dot curl x bar is 0. Okay, this is the second part. So next theorem is the necessary and sufficient condition for differentiability. This theorem is very important, that a necessary and sufficient condition for a Pfaffian differential equation x bar dot dr bar is equal to 0 is integrable is that x bar dot curl x bar is 0, or the Pfaffian differential equation x bar dot dr bar is equal to 0 is integrable if and only x bar dot curl x bar is 0. So this is very important theorem, that the Pfaffian differential equation is integrable if x bar dot curl x bar is 0. Okay, so the proof is in the two parts. The first part is necessary part, or assume that x bar dot dr bar 0 is equal to 0 is integrable. Is integrable right here. We assume that x bar dot dr bar is equal to 0 is integrable. This Pfaffian differential equation is integrable. And what do I have to show? To prove x bar dot curl x bar is 0. So x bar is obviously pi plus qj plus rk, where p, q, r are the functions of x, y, z. Right, this x bar as p x y z I plus q x y z j plus r x y z k. Right, in short, pi plus qj plus rk. And dr bar is what? dxi plus dyj plus dzk. And then x bar dot dr bar is what? p dx plus q dy plus r dz is equal to 0. And so x bar dot dr bar is 0 means p dx plus q dy plus r dz is equal to 0. So this is the vector form of this equation, p dx plus q dy plus r dz is equal to 0. So x bar dot dr bar is equal to 0 means p dx plus q dy plus r dz is equal to 0. Suppose this is the Pfaffian differential equation, given Pfaffian differential equation. Since x bar dot dr bar is integrable, it has a solution. Our assumption in this part is what? This x bar dot dr bar is integrable, means it has a solution. And suppose fxyz is equal to constant b, the solution of this equation number 1. Okay, numbering it is equal to 2. Suppose this equation is 2. So we know that the solution of the Pfaffian differential equation in xyz is the function of xyz is equal to some constant. So we assume that fxyz is equal to constant b, solution of this Pfaffian differential equation. And then obviously this complete derivative df is 0. What is df? Df by df x dx, df by df y dy, df by df z dz is equal to 0. This is complete derivative. Suppose equation number 3. So if equation 1 is exact, suppose this equation is integrable, means it is either exact or it has an integrating factor. That is, after multiplying integrating factor, it becomes a exact differential equation. So suppose 1 is exact differential equation, then 1 and 3 represent the same equation. If the given equation is exact, then exactly P is the dava f by dava x. Q is what? Dava f by dava y. And uh, uh, dava f by dava z is R. When if this differential equation is exact differential equation, then we know that the condition of exact differential equation. So we have these two equation number 1 and 3 represent the same equation. Represent the same equation in the exact. And if it is not exact, then it has an integrating factor. And after multiplying integrating factor, it becomes an exact differential equation. Because this given differential equation, this equation 1 is integrable, means it is exact or it is reducible to exact. So we have this, and therefore x bar is actually PQR in round bracket PQR, or write PI plus QJ plus RQ. This P capital X bar is what? PI plus QJ plus RK, right? Either in the form of IJK or write in round bracket PQR. So this is the another form of representation of vector. Then P is divided by x, Q is divided by R is divided by W. This is del F, del F. This is del F, or grad F. It's called grad F. Divided by xi, divided by yj, divided by zk is the definition of grad F, del F. And then curl x bar is del cross x bar, del cross x bar. Curl means del cross del F, and del cross del F is 0. Curl of grad phi is 0, is always 0. This is the theorem that curl of grad phi is 0. So del cross del phi, curl means del cross, and grad phi means del phi is 0. So we have it is equal to 0, and therefore x bar dot curl x bar is 0. Actually curl x bar is 0, therefore del cross x bar is what? X bar dot 0 bar is 0. And so this is the part 1. That is, our assumption is what? X bar dot dr bar is integrable. Then we have that x bar dot curl x bar is 0. But when if here we assume this given differential equation number 1 is exact. Suppose it is not exact. Suppose 1 is not exact differential equation, then there exists an integrating factor. Because the given differential equation, our assumption is this equation number 1 is integrable, means it has a solution. So it has a directly solution, that is, it has, if it is integrable, then it has a solution, and it has this equation number 1 has solution, means this equation is either exact or reducible to exact. That is, either it is exact or it has an integrating factor. That is, after multiplying that integrating factor, this becomes exact. So suppose this part is what? Suppose the x bar dot dr bar, the given equation 1 is exact. Suppose the equation 1 is not exact, then there exists an integrating factor, because the equation 1 is integrable. Then, and so it is either directly exact or it is reducible to exact. That is, after multiplying the integrating factor, it becomes exact. Suppose 1 is not exact, then there exists an integrating factor, say mu, some function of x, y, z, mu x, y, z, right? Just mu or mu x, y, z, such that mu p dx plus mu q dy plus mu r dz is equal to 0 becomes exact differential equation. That is, after multiplying that integrating factor to this differential equation, it becomes a exact differential equation. Suppose it is equal to 4. So now 3 and 4 represent the same equation. Now 3 and 4 represent the same equation, because and therefore dava by dava x is mu p. If the given equation, this equation 1 is exact, then 1 and 3 are same. 1 and 3 are same. Then we have this. But if the equation 1 is not exact, then after multiplying by integrating factor, it becomes exact, and therefore after multiplying by mu integrating factor, we have this. Now this equation number 4 and equation number 3, now because this equation becomes now exact, this equation number 4 becomes exact, And so it is exact means we have del y by del x, this equation number 4 and 3 represent the same equation, and therefore we have del y by del x is mu p, del y by del y is mu q, del y by del z is mu r, and therefore mu x bar is mu p plus mu q plus mu r. Mu x bar, what is mu x bar? That is multiplying mu by x by mu. So we have this x bar is what? X bar is PQR, and mu x bar is what? Mu p plus mu q plus mu r. And then mu p is del y by del x, mu q is del y by del y, and mu r is del y by del z. And this is actually del f. This is del f, because del f is what? Del y by del x I, del y by del y j, del y by del z k. That is gradient of f, grad f. Grad f is what? Del y by del x I, del y by del y j, del y by del z k. And now curl mu x bar is del cross del f. Curl mu x bar. This is mu x bar. Then curl mu x bar is what? Del cross del f. And del cross del f is 0. Del cross del f is 0. Curl grad phi. Curl grad phi is 0. Curl grad phi is 0. This is curl grad phi is 0. So it is equal to 0. And then mu x bar dot curl mu x bar is what? Mu x bar dot, and curl mu x bar is 0. So we have answer 0. And hence mu x bar dot, we have mu x bar dot curl mu x bar is 0, and implies x bar dot curl x bar is 0 by previous theorem. That is, what is the previous theorem? That x bar dot curl x bar is 0 if and only mu x bar dot curl mu x bar is 0. That is, if mu x bar dot curl mu x bar is 0, then x bar dot curl x bar is 0. So we have, by using previous theorem, here we have mu x bar dot curl mu x bar is 0, and hence x bar dot curl x bar is 0. Hence the first part, that if the function is x bar dot dr bar is integrable, then x bar dot curl x bar is 0. Now the second part, sufficient part, that assume that x bar dot curl x bar is 0. And now what we have to prove? X bar dot dr bar 0 is integrable. This Pfaffian differential equation, x bar dot dr bar 0 is equal to 0 is integrable. X bar dot dr bar is equal to 0 means pdx plus q dy plus r dz is equal to 0. Equation number 1 is integrable. So we assume that z is equal to constant. Treat z as a constant. So dz is equal to 0. Actually, this is Nathaniel's method, that treat z as a constant, and then dz is equal to 0, and therefore equation 1 becomes pdx plus q dy is equal to 0. This is the Pfaffian differential equation in two variables, and we know that every Pfaffian differential equation in two variable is integrable, has a solution. So it has a integrating factor, say mu. That is, this Pfaffian differential equation into variable is always integrable, means it has a solution. So it is integrable means either this differential equation into variable, that is this equation number 2, is integrable, or is exact, or it is reducible to exact. Suppose it is exact, then 1 is its integrating factor. But if this equation is not exact, then it has some integrating factor, suppose mu, and after multiplying by mu to this equation number 2, this becomes exact. So suppose this is the Pfaffian differential equation in two variable, this equation 2, and therefore it has an integrating factor. It is integrable, because the theorem is what? Every Pfaffian differential equation into variable is integrable. So it is integrable means we have its solution, and so either it is exact differential equation or reducible to exact. Suppose it has an integrating factor, say mu. So after multiplying by mu, so we have mu p dx plus mu q dy is equal to 0 becomes exact. Suppose this equation to itself exact, then mu is 1. and therefore it has a solution. Let it be phi x y z is equal to constant be the solution of this differential equation, because this is integrable. Now equation 2 is integrable, so it has a solution. Suppose phi x y z is equal to c1 be its solution, then we have delta phi by delta x is mu p, so it's and delta phi by delta y is mu q, because after finding d phi is what, delta phi by delta x dx, delta phi by delta y dy is the d phi is equal to 0, and if you compare these two, then mu p is what, delta phi by delta x, mu q is delta phi by delta y, and then p is equal to 1 by mu delta phi by delta x, and q is 1 by mu delta phi by delta y, and therefore equation 1 becomes, this equation number 1 becomes, after substituting value of p and q, 1 by mu delta phi by delta x dx, 1 by mu delta phi by delta y dy plus r dz is equal to 0. Multiplying by mu, we have this mu r dz is equal to 0, and then delta phi by delta x dx, delta phi by delta y dy, add this term delta phi by delta z dz, and then subtract the same term delta phi by delta z dz plus mu r dz is equal to, that is, add the term delta phi by delta x, delta phi by delta z dz, and subtract the same term, and this is d phi, delta phi by delta x dx, delta phi by delta y dy, and delta phi by delta z dz is d phi plus this term, two terms, mu r plus mu r minus delta phi by delta z in bracket, and then into dz is equal to 0. Equation number 3. Let nu is equal to, nu is another notation, nu is mu r minus delta phi by delta z is suppose denoted by nu. Obviously this nu is the function of x y z. Then we have mu r is equal to nu plus delta phi by delta z, and therefore equation 3 becomes, this equation 3 becomes d phi plus nu dz is equal to 0. Equation number 4. Suppose this bracket is nu. This is equation number 4, that d phi plus nu dz is equal to 0. Since x bar is pqr, this vector x bar, then mu x bar is mu p plus mu q plus mu r, and mu p is delta phi by delta x, mu q is delta phi by delta y. This mu p and mu q are delta phi by delta x, delta phi by delta y, and mu r is this, and nu plus delta phi by delta z, and then we write this as addition of these two vectors, delta phi by delta x, delta phi by delta y, delta phi by delta z plus 0 plus 0 plus mu. If you add these two, then we have this, that is delta phi by delta x plus 0 is delta phi by delta x, delta phi by delta y plus 0 is delta phi by delta y, comma delta phi by delta z plus mu is this term. And this is del phi, this vector delta phi by delta x, delta phi by delta y, delta phi by delta z is del phi plus 0 0 mu. And then curl mu x bar is del cross mu x bar, del cross, and this mu x bar is this del phi plus 0 0 mu, and then del cross del phi, distribute this del cross on this bracket, so we have del cross del phi, then second term plus this term, plus sign, del cross 0 0 mu, and del cross del phi is 0, is always 0 for any phi. Del cross del phi means curl grad phi is 0, and this cross product of these two vectors is ijk. Del means operator, delta phi by delta x I, delta y j, delta z k. So coefficient of ij are delta x, delta y, delta z, and 0 0 nu, and then solve this determinant. We have I in bracket delta nu by delta y minus 0 minus j delta nu by delta x minus 0 k delta 0 minus 0 in bracket. So delta nu by delta yi, delta nu by delta minus delta nu by delta xj, and is equal to delta nu by delta y, minus delta nu by delta x, and 0. So mu x bar dot curl mu x bar is this. Mu x bar is this vector delta phi by delta x, delta phi by delta y, nu delta phi by delta z. This is mu x bar. Mu x bar is this vector, and curl x bar is this vector delta nu by delta x, minus dava nu by dava x, dava nu by dava y, not dava nu by dava x, dava nu by minus dava nu by dava x 0. And that dot product is what? This into this. The dot product of the two vector is what? Multiplication of coefficient of I, dava phi by dava x into dava nu by dava y, plus dava phi by dava y minus dava nu by dava x is minus dava phi by dava y, dava nu by dava x, and this into 0 is 0. So as x bar dot curl x bar is 0, this is our assumption, and therefore mu x bar dot curl mu x bar is 0 by previous theorem. And so this is equal to 0. What we have? Dava phi by dava x dot dava nu by dava y minus dava phi by dava y, dava nu by dava x is 0, and this is the Jacobian of dava phi n dava xy. This is the Jacobian dava phi nu dava not nu, n dava phi nu dava xy. And this is equal to 0, and therefore phi and nu are functionally related. That is, there exists a relation. This phi and nu are functionally related because this their Jacobian is 0, and that is, there exists a relation between phi and nu not containing x or y explicitly. So this is the theorem that if this Jacobian dava phi nu dava xy is 0, means there is a relation between phi and nu not containing x or y explicitly. Actually, this is the theorem in the previous chapter, that if the Jacobian is 0, then phi and nu are what? Related and not containing x or y explicitly. And let it be that the relation between phi and nu be this psi, phi nu is equal to 0. So as the Jacobian is 0, therefore phi and nu are functionally related, and we write the relation between the phi and nu as a psi, phi comma nu is equal to 0. And so from equation number 4, we have nu is a function of phi and z alone. Nu is a function of phi and z alone from equation number 4. So this is equation number 4. So nu is a function of phi and z alone. After solving this, that is, suppose nu is equal to nu phi z. That is the function of phi and z alone. This equation number 4 indicates. And so therefore from equation number 3, we have d phi plus nu phi z dz is equal to 0. Value of this quantity. Mu r minus dava phi by dava z as nu phi z dz is equal to 0, because this is what? A function nu, it is nu, this is nu, so write nu dz, and nu is what? The equation number 3 is what? D phi plus nu dz is equal to 0. Actually, this is the equation number 4. So write from equation number 4 d phi. Here right, we have from equation number 4, right? 4 d phi plus nu, and that nu is the function of phi, and z dz is equal to 0. And it has a solution. Let it be capital F phi z is equal to 0. The solution of this equation is equal to C2. So using this in equation phi xyz is equal to C1, we get u xyz is equal to C3 as a new function, and which is the solution of the differential equation 1. And so the differential equation 1 has solution, means differential equation 1 is integrable, and hence theorem. That is, the given differential equation 1 is integrable. So this is the second part, that if the x bar dot curl x bar is 0, then the Pfaffian differential equation x bar dot dr bar is equal to 0 is integrable. So this is the important theorem on the Pfaffian differential equation. So we'll start next chapter in the next lecture.